Question 4. This question is about electrical resistance. The graph shows the variation with temperature T and the resistance R of an electrical component. So we have here, this is in ohms, and this is temperatures in Kelvin. So a student hypothesizes that the resistance is inversely proportional to the temperature. Use the data from the graph to show whether the hypothesis is supported. So for an inverse relationship, we basically have this, that x, y is equal to a constant, or x is equal to a constant over y, or y is equal to a constant over x. Those are three different forms. Basically, it means that as the one is going up, as the one is increasing, the other is conversely decreasing at the same rate. So if you double x, if this is 2 times x, it will be divided by 2 for y to give you the same constant. Now the way that we can check for an inverse proportion is we can just take 2 points. So I'm going to take this point over here. I'm going to take this point over here, where that one over there, and I'm also going to take this point over here, that point over here, and I'm going to find the R and the T value for that. So I'm going to find my T and R value for each one of those, T and R value. Now, if they are proportional, let me call this T1 and R1, T2, R2. If this is a inversely proportional relationship, then T1 times R1 and T2 times R2 should equal the same value. They should both equal the same amount. So we'll get those two, see what happens, and we'll multiply them out. So at T1, looking at T1, I get here, I am here, so that's halfway between there, so that's 275, and here we are, this is 4,000, 4,000, each one of these must be 100, so this is going to be about 4,700, here, 4,700, so I'm going to get, for that one, I'm going to get 275 times 4,700 for that, and I'll multiply that out. And for this one over here, I'm at 325, and my resistance here is there, so it's 700 times 700. Work both of those out. Let's do that. So we get 275 times 4700, and you get 1292,500, that amount. And I multiply this one, 325 times 700, and I get 227,500. So we can see here that there's a big difference. Here we have 227,500, and here we get 1.29 million. So therefore T1 times R1 is not equal to T2 times R2. Therefore T is not inversely proportional to R or the reverse. So then it says a second student suggests that the relationship is of this form, of LGR is equal to A B over T. So we get the log of R is equal to A plus B over T. And the student plots the graph below. Error bars have been included for the sake of clarity. So here it's plotting log of R against 1 over T. So now we have this. If we look at this, we could write this in the form y is equal to mx plus c. If we look at this, the y corresponds to my log of r. My m over here, the m is b. The x is 1 over t, and my c corresponds to a. So this, by plotting it the way that the student has of log against 1 over t, we can get, it should be in a form of a straight line if the data does support this theory. So going on from there, explain how the graph drawn could be used as evidence to support the student's suggestion. Well, can we draw a straight line that goes through all the error bars? Well, I think you probably can. So we probably can. Now you would be able to do this much better because you could have a ruler, but we can draw a straight line that goes through all the error bars. So we have a straight line, SL, that goes through all the error bars. Okay, and this over here would be your intercept, your vertical intercept, and obviously you're going to have your slope. So use the graph to determine the constants a and b. So as I said before, we've got that the log of r is equal to a plus b over t. So this a will be your vertical intercept. So it's this value over here. And so that's about minus 1.9 it works out to be. It's in that in range. Anywhere in that range, about minus 1.9. You could get an answer for this anywhere in the range of 1.7, minus 1.7 to minus 2.3. Okay, depending on how you drew that line, because you could draw that line slightly different. But make sure that when you draw this line over here, it does pass through all the error bars. So when you draw this line, it's going through all those error bars. Now, so that's actually looking at what I've just found there was for B, which is actually for A. So I've actually found A there. I found this value over here. Now to find B, you need to find the slope. So in finding the slope, you use as much of the graph as possible. So I would use the whole graph. I'll draw a line right the way across like this. Now obviously mine's not going to be so good because I'm doing it a bit rough. But B is going to be the slope. So this is going to be your change in the 1 over t, and this is going to be your change in the log of r. And that will give you your B value. So let's have a look and see what it is. Well, this is going from what I said. Well, actually, this is not minus 1.9. This one actually went past, wasn't it? So this was about, but let's say it's about minus 2 there. So it's minus 2, and it goes up to about over here. It goes up to about 4.2. So we're going from minus 2 to 4.2, so we're going up there about 6.2 about, and my across here I'm going across 4, but notice here that this is 10 to the minus 3, so got to be a little bit careful about that. So that's going to be, this is going to be 4 times 10 to the minus 3. So when I find the slope, which I'm actually finding B here, my slope, that is going to be 6.2 divided by 4 times 10 to the negative 3. So I'm going to calculate that. So I'm going to get 6.2 divided by 4 exponent to the -3, and I get my slope is equal to be about 1550. Now the values that you could have got for this, the range that you could have got was from about 1500 to 1700, so as long as you get within that range. And then it says use your answers in B2 to determine a value for the resistance of the component at a temperature of 260 Kelvin. So we've got our formula here that we're going to use. We're going to use the log of R is equal to A, but we've said A was in this range over here, so let's just use, say it's about -2, and then it's plus my value for M, we worked it out to be about 1550. It's in between here, so I'm going to put 1600 just to work this out, and my temperature is 260. So I work that out. I get -2 plus 1600 divided by 260, and I get a value of 4.15. Now that's equal to the log of R. Now this log of R is to the base 10, so R is going to be 10 to the 4.15. So I say 10 to the x of 4.15, close brackets, and I'm getting about 14,125 would be your resistance for your, not your resistance, sorry, for the value of, yeah, for the resistance of that. So that would be so it's 14,125 would be that value.